Alright, hey everybody, how's it going? So today we've got a couple of things that you guys are going to be doing. You're going to be learning about motors and how to control DC motors as opposed to servo motors. Transistors, which is what we're going to use to control our motor in this case, and you're also going to be learning about distance sensors. We're going to learn one new sensor, we're going to learn about a motor and how to kind of control them. So we got a little bit of sensor and a little bit of output. Now we're going to try something a little bit different today. You guys are going to build two simple Arduino kind of systems. One is going to be running your DC motor using a transistor as a switch, and the other is going to use a distance sensor to turn on a light when an object gets to a certain distance. And so then what I'm going to have you guys do, and what your homework is going to be, is to combine these two systems together to have something where essentially you have a motor that is running until an object gets too close. Right? And you guys are going to try and do that and code that on your own, and then I'm going to post a video solution if you guys need it. So we'll go ahead and start off. The first thing that I'm going to have you guys do after watching this video is you're going to build this motorized pinwheel. This is Project 9 from the Arduino book. And it's got a great little write up here that you guys can read all about how this goes on. It's got the example code. It's actually a really short section of code. And it's got the build instructions right here. So you'll be using a button. And then this is our transistor. This is a thing called a MOSFET, M-O-S-F-E-T. To control your just DC motor here. Now I actually went ahead and built this here in Arduino so you guys can see this is an example of what it could look like. There's a few key components. Here's our little button, right, which is just simply being read on input 2 here, whether or not the button is being pressed. And then we have our MOSFET transistor. And then we have our little diode here. Now this diode is important. They talk about this in the book, but it prevents the backflow of electricity from this motor as it's still spinning. So one thing I do want to point out with this is that you guys need to find and use this exact transistor. Oops. If you use a different transistor, it will not work. So you guys need to use that transistor. Now how you find it is if you go over here, you can actually just, let me move my screen here so you guys can see. You can just search in under your components, just type in MOS, and you're looking for this guy, this NMOS transistor or MOSFET, right? That's an NPN type transistor. Don't really need to know about that, but this is the one that you need to use for this program to actually work. And there's a little bit about transistors. You'll notice they have these three different spots. They've got a gate, they've got a drain, and they have a source, right? A gate, a drain, or a source. You'll also see these referred to, if you actually look at a diagram for them, you'll actually see these referred to as base, collector, and emitter. Right? So this would be your source, this would be your drain, and this would be, what did I say it was? Your gate, right? So this would be your gate, this is your source, and this is your drain. And I've included a video from Veritasium about how transistors work. It's a good kind of short little video that you guys can watch if you're more interested, but essentially I'll give you guys the rundown. The way it is, a transistor, one of their uses is as a digital switch. And the way it is that you have essentially a voltage that wants to flow through here. So you have a current that wants to flow from the collector to the emitter, from the source to the drain. So it wants to flow that way, but it can't, right? Because the transistor is essentially blocking it. It's an open switch, so it can't flow. But because of the way the transistor works, if I apply a small current here to the base, right, or to that gate, then I can allow that current to flow. So if we go back to our circuit here and look at what's going on, right here I have my 9-volt battery, which is actually powering this motor. And that's because the Arduino itself can't put out enough current to make this motor turn properly. So I have to use this 9-volt battery to actually power it. So normally, I just go positive through one end of the motor, and then it'd go to the negative, and then the motor would just run. But because I want to control it, what I'm going to do is in order for the current to go from the negative to the positive, or the positive to the negative, I need to run it through this transistor. Okay, so my gate, or that little base pin, right, this guy right here. By the way, this is the circuit schematic for a transistor. But that guy is right there, and that's going from pin 9. So that's how I'm going to control whether or not there's a current right there on the base. Right? If I put a current out to that base, then it'll allow electricity to flow between the other 2 points. So if I put a high signal from this base here, then it'll allow the current to flow through. So if we look at what's going on, right, we have the positive, it goes through the motor, and the negative, in order to get to the negative, it can't go through this diode here. In order to get to the negative, it needs to go through this transistor, right? over to the negative, right? So that's the only route for the current to flow through the motor, is it actually goes through this transistor as well. And so I can turn on this transistor, I can turn on and allow that current to flow using pin 9 here, right? And then the button is just me sensing if the button has been pressed. And if we look at our code here, what's actually going on, right? It's essentially what we get is I've got my switch pin and I've got my motor pin. I got a switch state, so in my setup, the motor pin is an output, so pin 9 is an output, and the switch pin is an input, so pin 2 there is an input, sensing if that switch has been pressed. You check this, the state of the switch. If the switch state is high, so if the switch has been pressed, then you are going to write on 9 here, you're going to turn 9 on high, and you're going to turn the motor on. Otherwise, you're going to turn the motor off. So if we want to see what that actually ends up looking like, right here we can notice the button hasn't been pressed, and the motor RPM is at 0. Right? If I press the button, then it turns on the motor. Right? So it's kind of cool. And then if I let go, it turns it off. So that is the first kind of thing that you guys are going to do. The other thing that you guys are going to work through and learn is we're going to talk about a ultrasonic distance sensor, right? And that looks kind of like this. This one is called ping. There's a couple in there. We're looking for this one, and we're going to be using this one called ping that has 3 pins. There's another that has 4 pins. It's a little bit different, but we're going to use this one today. What I recommend doing here is actually, I didn't even put this together. If you go here to the Arduino, under the components and the stars, you can go to Arduino. They've got a bunch of these that you can just kind of pull out, which are really nice. And I just go down here to the ultrasonic rangefinder. Click on that and drag it out here. All right, then if you go to code, it'll give you the code. You may have to change it from blocks to text, but go ahead and change that to text, and it gives you the code for how this works. So what this is doing here is, if we start the simulation, open up my serial monitor, what it is if I click on this, it'll tell me the distance that an object is away in my serial monitor here. So right now that object is 77 inches away, or 196 centimeters away, right? Which is nice. That'll actually tell me that. So I can sense how far away something is. Now, how does this actually work? Well, if we dive into this, you'll notice it has like if you see one of these in real life, it's 2 little like speakers. And what it does is it sends out an audio signal. So it sends out like a beep that's at a range that we can't actually hear. But it sends out a beep. It's like echolocation. It sends out a beep, and then it waits for a return, right? So I believe that this can sense things that are up to, let's see what the range is on this. We start the simulation. The range goes up to, I think it's like 132 inches or something. Yep, it goes up to 132 inches, and it goes down to the lowest is, you can sense up to 1 inch away. And then once you get closer than 1 inch, then it says 132, right? Or if you're outside of this cone, right? So like echolocation, the sound kind of travels in the cone and then it responds back in the cone. So similarly, if you're outside the cone, it'll just return the high value of 132 inches or 336 centimeters. So you can sense how far something away is. And then if we look at the code as to what's going on here, right? It kind of talks about what is going on. And so what it does is we've got a few things. We've got a couple of variables, inches and centimeters. Right? I'll come back to this whole long thing here in a second. But what you do is essentially start up your serial monitor, and then you measure the ping time in centimeters using this code up here, and then you convert that to inches. So what you're doing is you're essentially just continually monitoring for pings. What's going on in the loop. Now you'll notice here, the loop, it says the key thing that's actually doing is it's using this little command here, this little variable. The centimeters is this number, right, times whatever this variable, the read ultrasonic distance is, right, whatever that number is. And that's actually reading the ultrasonic distance. Now what they do up here is they create this a variable. Now it's a long variable, so it can be a big number, which is what you can end up getting, because what you're reading actually here is the time in, I think, microseconds is what it is, that it takes the pulse to return. So long is just like a variable that can be a lot of digits. Okay, and so there's this variable called long. Read ultrasonic distance is the name of the variable, and then it's got in here a couple of other variables, the trigger pin and the echo pin. You'll notice that is 7 and 7 here. So if we look on here, it's connected out at pin 7. And so what it does is it says, hey, trigger pin, pin 7, is an output. Okay. Then we're going to write it at low. We're going to delay a little bit. Then we're going to write it at high. We're going to send out a ping, right? Then we're going to write it at, and we're going to wait a second. Then we're going to write it at low, right? And then we're going to return, right, using this pulse in command. And this is the key command here that this actually uses, is it records at the echo pin, right, which is now an input, because we said pin 7 is now an input. It's waiting for it to go from low to high to low. That's what this high here means, is waiting for it to go from low to high to low. So we return the value here, this read ultrasonic distance. The value that we actually get is the amount of milliseconds that it takes this echo pin to go from low to high to low. Right? So it's reading the amount of time of the pulse. Now, I'm not particularly worried that you guys know exactly what this means. One of the nice things when we use these sensors and when we use Arduino is we can essentially borrow code that's already been written that kind of works, and then we can use that and make it our own, right? So here's a code that actually works. It gives us, you know, our distance in inches and our distance in centimeters pretty well. Gives those as variables. So I have a variable named inches and a variable named centimeters, right? And so this actually works. This piece down here is converting it to centimeters and then converting it to inches. So that's what's actually happening in the loop. So what's happening is it's continually running this kind of value here, which is globally, it's like this is essentially a set of instructions that it can run whenever it says this, right? It runs that and it continually converts it to centimeters and inches. Okay, so this is running any time that it's going through the loop here. And that's that. So how can we actually use this? Well, what we can actually do is, let's say I wanted to use this to turn on a light when something reaches a certain distance. Well, I'll go ahead and I'll put in a little light here. So if I go back to my basic components, I'll go ahead and put in an LED. I know I need a resistor for it. And let's go with 150 ohms. And we'll connect that to, let's say, just pin 8. And let's make it turquoise, because why not? And then the ground is going to go to the ground there. And we'll make that black because it's going to ground. Right, so if I write pin 8 at high, right, it'll send 5 volts through there, through the LED to there. Right, so that's what's happening there. Now, if I wanted to make this LED turn on, what I need to do is in my setup, I can go ahead and pin mode, and I'm going to name pin 8 as an output. Right. So now I'm saying, hey, pin 8 is an output, so you're going to be sending voltages out there. And then in my loop, after it runs through all of this, what I want to say, hey, if, and then I'll throw in my condition for that if. So let's say if inches is greater than or equal to, why not? Is greater than or equal to, let's say, 50 inches. So if an object is farther away, is 50 inches or farther away, right, then I'll open up my bracket and I'll put in what I want it to do. Then I'll say digital write pin 8, which is my LED pin, at high, right? Semicolon. And close curly brackets, and then else. So if that's not the case, then I want digital write pin 8 at low. Close that bracket, right? So within this loop, right, I'm constantly reading the ultrasonic distance. I'm reading how long it takes that ping to come back, and I'm using the amount of time it takes for that ping to come back to find the distance away in centimeters. And you do that using the speed of sound. And then I'm converting those centimeters to inches, so I have two variables, inches and centimeters. And now I've said, hey, I created pin mode 8 here is an output, and if the inches, that variable that I'm continually getting back, if it's greater than or equal to 50, then you're going to turn pin 8 on at high, and otherwise you're going to put it on at low, so the light's going to be off. So if we start the simulation and see how it actually ends up working, if I turn this on, right now it's further than 50, so it's going to be high, and then if it's less than 50, then it's on at low. And I can go right, turns on, turns off, right? So that's that. Pretty straightforward, kind of cool. So my challenge to you guys, what I would like you to do, is I'd like you to combine these in some way. Can you use an ultrasonic rangefinder like this, or a distance sensor, right, to say, hey, here I have a motor that I can control using this pin here, right, pin 9. Right? Instead of controlling it with a button, can I say, hey, I want this motor to run until an object is a certain distance away. And once that object gets to a certain distance, I want my motor to stop. So that's my challenge for you guys. I'd like you guys to give it a try. And if you need help, I'm going to post my answer key. You guys can check that out and check that video out as well. But I'd like you guys to try it on your own for sure. And that is that. So good luck. Hope it goes well. Hope you guys are learning a lot and enjoying this and that life is still good. So over and out.